What is the first member of alkyne series? Obviously ethyne.
C2H2, yes ma'am.
Right?
Yes ma'am, C2H2.
Or we can write it as acetylene. Ethyne or acetylene. Sometimes the name is confusing. It's acetylene. Ethyne is also named as acetylene. Pure acetylene is narcylene. Narcylene is pure acetylene. Acetylene purpose is to used in welding purposes. Okay, used in welding or in the form of acetylene flame. Acetylene flame. So this is producing a lot of energy when we burn it, and huge amount of energy produced is help in the welding. Okay.
Yes ma'am.
Name is nomenclature. How we did the nomenclature of it? Already did the nomenclature, right? Alkyne. Or we can name it in the common form as acetylene or substituted acetylene. Substituted acetylene.
No, acetylene is common name.
Like methyl acetate.
Acetylene is common name.
This is methyl acetylene, right? Methyl acetylene. Phenyl acetylene. Got it, na?
Yes ma'am.
Moving on to next point, which is structure of ethyne. Carbon is sp, right? We already discussed about the structure, I guess, right?
Yes ma'am, I have already discussed.
Sp means 50% S character, and bond angle is 180 degree. Let's discuss about the preparation of it. First preparation is call-based electrolysis. Call-based electrolysis. electrolysis, right? In the last part.
Yes, ma'am.
What I told you to do is remove this CO2 and create a multiple bond in between the two. Here. Got it? Okay, in the format of that mechanism, you want me to write it down?
Yes, ma'am. How the mechanism?
So it's an ionic species. Positive. This is at anode. Anode oxidation will happen, means loss of electron. So it will lose 2 electrons. Will convert that to CO2, right? Like this. At anode, at cathode, what will happen at cathode? H2O, 2 electrons, H2 and 2 OH minus. Got it or no?
Yes, ma'am. Got it.
So overall we can create then the reaction final product. This is the final product of the reaction. CO2 is also the final product. Hydrogen is also the final product. And potassium and OH from here, KOH. Right? Final product is like we do electrolysis of it. If you write R, C, triple bond Cr plus CO2, KOH and hydrogen gas. Any doubt, any problem so far, Himansh?
Ma'am, no problem.
Hydrolysis of carbides. Hydrolysis of carbides. Now, this is also very important. So, carbide is what? Carbide is carbon triple bond carbon. So, if we are having calcium carbide, Ca, C2, written as like this. Now, calcium, negative, positive. Oh, okay, one second. So, in this CaC2 now, remember that negative, negative and calcium carries 2 positive charges. So, this is calcium carbide. So, when we do the hydrolysis of it, hydrogen will approach over here, right? And calcium hydroxide will eliminate out. Is that clear or no?
Yes, ma'am. Clear, ma'am.
If there is any problem you find over here, you can ask me.
Yes, ma'am.
Clear?
Yes, ma'am. Clear, ma'am.
Oh. Similarly, how we get this calcium carbide? Calcium carbide is obtained by the reaction of calcium carbonate. When we heat calcium carbonate, we'll get calcium oxide and CO2. Calcium oxide will react with 3 carbon and will convert to calcium carbide. And filtrate out. Got it or no? If we are having magnesium carbide, this is calcium carbide. If we are having magnesium carbide, Mg, magnesium is having 2 valency and carbon is having, no, it's right, magnesium carbide is right, Mg2K3. Now how it exists, what is the structure of it? Only 2 are there, no? This is negative, or either you can create it like this. Two minus, so 1 Mg, 2 positive, another Mg, 2 positive. When we do the hydrolysis of it, it will be converting to magnesium hydroxide. Got it or no?
I got it, ma'am.
Any doubt, Himansh, so far? Tell me.
Ma'am, no doubt, ma'am.
Okay, fine. Let's move on to the third preparation then.
Yes, ma'am. You can.
This was the hydrolysis of carbides, second. Now moving on to the third one. From trihalides. From iodine. From iodine. So let's discuss about it. This is again very important. Very important. It was also asked there in your PYQs. CHI3, 6Ag, CHI3. Although the manner in which they are presenting will make us feel like we don't know this reaction, but this is how it actually taken in the simple form. So I3, AgI, 6 AgI remove out. H, C, triple bond C, H. Got it or no? Tell me. Himansh?
I got it, ma'am.
Similarly, we are having, let's say, CH3, C, I3, CH3, no? Similarly, we will again to take Ag, 1, 2, 3, C, CH3. Heat it, 6 AgI will eliminate out and we will get CH3C, triple bond to C, CH. Any doubt, Himansh, so far?
Ma'am, no doubt, ma'am.
Now moving on to another fourth method of preparation, which is double dehydrogenation. Hydrohalogenation. This is again important one, usually asked in your questions. So R, CH, Br, CH, Br, and R. Alcoholic KOH, and NaNH2. And alcoholic KOH and NaNH2. So we are applying it over here, or we can either use directly 2 molecules of NaNH2. NaNH2. So we are getting what? R, C, triple bond C, R, and 2 NaBr. Got it or no? Now, how this mechanism happens? Let's discuss about it. Mechanism of the reaction. Mechanism of the reaction. Mechanism is like, have a look. Like this. Alcoholic KOH, KBr eliminate out, H2 eliminate out. How do we do that? See, alcoholic KOH is having the ability to remove this. Remember we did this reaction previously as well. Remember or no?
Yes,
elimination.
Yes, ma'am.
Even E2 elimination, in that we did discuss. Alcoholic KOH removes the hydrogen and anti-elimination. Remember or no?
Yes, ma'am. I remember.
So we will get what? Br, CH, double bond, CH. Now we require NaNH2. See, NaNH2 is very strong base. Then alcoholic KOH. Okay, that is the reason we can easily remove this out. Got it or no? Himansh?
Yes, ma'am. Got it, ma'am.
This is the reason we are removing this second hydrogen from this alkene. And we are C, okay, so it's hydrogen and we are. Again we are getting triple in between CH. Alkyne. If you are finding any difficulty, you can ask Himansh.
No.
Tell me.
No problem.
Okay. topic also there in this only, isomerization. Isomerization means if we are heating one type of alkyne alcoholic KOH, or if we are using NaNH2, any of the two. So triple bond will be shifted towards the center. Triple bond will shift toward the center like this to form isomeric structure. Okay. So it's, you will say over here alcoholic KOH will do this thing. What we can say, internal to terminal to internal it will create, but NaNH2 will do what? It will create it to terminal. Okay, clear?
Yes, ma'am. Clear, ma'am. Yes, it will go to center. Now, the triple bond will move to center.
In alcoholic KOH, it will move to center, but with NaNH2, it will go to the end position.
Ma'am, it will go to either end, we can say.
Obviously. By the way, until and unless NaNH2 is there, NaNH2 is a strong base. So it will easily remove this hydrogen. So we can show it in two steps. Because until and unless NaNH2, which is a base, it will not produce hydrogen, it will produce Na positive. But if we supply H2, an acidic medium, acidic medium to it, right? So if we provide any acidic medium, H positive, then it will ultimately result into the formation of alkyne. Got it?
Yes, ma'am, got it.
Fifth reaction, double dehalogenation reaction. This is again an important one. Double dehalogenation. So R, C, X2, C, X2, R. Zinc dust, alcohol as a solvent, and we are heating it. So when we are heating it, X2 removes out, X2 removes out. Okay? And we will get a triple bond with Zn, X2, 2 zinc, X2 will remove. Okay, Himansh?
Yes, ma'am, okay, ma'am.
Zinc dust, heating with the zinc dust. So tetra halides will be converting to alkynes. Now, another reaction is lower alkyne conversion to higher alkyne. Lower alkyne to higher alkyne. So how to do that? Have a look. This is an alkyne, right? If we react it with the base or metal, suppose sodium metal, so it will be converting to, because this hydrogen is acidic, right, Himansh? due to 50% S character of triple bond. We'll get a negative over here and a positive over here. This will further react with any alkyl halide. This will further react with any alkyl halide. So we can tag this negative over to this R group and X will remove out. So H, C, triple bond C, R and NaX will remove out. NaX will remove out. So you can clearly see that we have increased the carbon chain by this method. Right? Okay. Manj, what happened?
Yes, ma'am.
No problem.
Ma'am, if it is more, ma'am, acidic, it has 50% S character, ma'am. Means we can say it's more electronegative, ma'am. We can say it will attract electrons.
So it will attract the electron. So it will try to pull the electron density. This carbon is acidic, huh? This carbon is having more S character, right?
Yes, ma'am. Means it pulled all electron and H plus and C minus are forming on this.
Elimination, yeah. Easily it will eliminate H positive out, right?
Yes, ma'am.
Correct. So R, C, triple bond C, negative, Na positive. Depending upon which type of alkyl halide we are attacking on. If we are attacking it on 1 degree alkyl halide, that will be easy. No issues with that. We will get a yield in good amount of the formed. Say triple bond C, CH2, CH3. So high yield. But if we are attacking it on a 2 degree, so we will get a poor yield because bulkiness, right? We will get a poor yield. But if we are having a 3 degree, then we will say no elimination, no substitution will happen. It will eliminate. Elimination product will be favored. CH3, C, double bond CH2, CH3. It will eliminate this hydrogen out from this. We will get R, C, triple bond CH. Because this group is bulky. Okay, so if a bulky, always remember elimination will dominate over substitution. Got it? Imanj?
Yes, ma'am. Got it, ma'am. For bulky groups only, elimination will be more prior than substitution. Yes.
Correct. Okay. And all these reactions are only possible because these are terminal alkynes. So they are having acidic hydrogen. Only remember this is we can do this reaction with terminal alkynes only. Terminal alkyne will already do this reaction because it is having ending hydrogen, not having any other group with it. Right now, Himansh?
Yes, ma'am. No, because on a term, ma'am.
If internal no hydrogen will be there on sp carbon, right now?
Yes, ma'am. That's the reason we can say. I mean, that we can try for sp carbons only it will occur.
Yes, sp?
Hybridized carbon with having one hydrogen.
And one hydrogen is only possible if they are only in the terminal position. Got it now?
Yes, ma'am. Got it, ma'am.
Let's discuss about the properties of alkynes now. properties of alkynes. So moving on to the physical properties. Yeah, gas. First 3. They are gaseous in nature. Next 8. Next 8 are liquids. And other member, higher member are solids. Weakly polar in nature. Because of triple bond. Lighter than water. Solubility to be immiscible in water because they are hydrocarbons. But soluble in organic solvent. Organic solvent. Got it? Or molecular weight increases, melting point increases, boiling point increases, solubility in organic solvent increases. It will increase. Got it? Now acetylene. It is the colorless gas. Order is like garlic order. Due to phosphine impurities. Impurities like phosphine. Okay? Himansh.
Ma'am, in that melting and boiling point, or there will be no exceptions at all. It will be always goes on directly proportional to the molecular weight, we can say, ma'am.
Melting point, yeah.
Yes, ma'am.
Exactly. As we are increasing the molecular weight, obviously their melting point will increase. Moving on to another property, that is the chemical properties. Chemical properties. So the point is that alkynes are less reactive than alkenes. Obviously. Alkynes, kenes. Because pi electron there in alkene are more closely held. Okay, because that triple bond carbon are electronegative in nature, so they will tightly hold that pi electron cloud. Okay, so chemical reaction that we're gonna discuss in this chapter is acidic nature. You already know about it in the previous class, right? Previous section. And addition reaction, just like alkenes. Oxidation reaction and polymerization reaction. Polymerization reaction. Let's discuss them one by one. Acidic nature. Let me save it first, Himansh. So as I told you, that triple bonded carbon, the hydrogen attached to it is acidic due to 50% S character of sp hybrid carbon, right? So if you want to know the acidic order is like alcohol, then water, then methanol, then water, then alcohol. As I told you, we didn't discuss it, I guess. Yes. In alcohol, phenol and ether chapter, we will discuss this thing. That alcohol are less acidic than water, but yes, methanol is more as compared to water. Then is alkene. Okay. Then is alkene. Then NH3. Alkyne, sorry. Alkyne, NH3. Then alkene. And then alkene. Okay. So this is alkyne, alkene or alkene.
This is acidic nature, this is order for ma'am.
Exactly. Acidic nature. Let's discuss about reaction with steam. Reaction with sodium. Not steam. Sodium. We already did this reaction, right? When I told you how to create this reaction, see, with sodium, we are getting this salt. Sodium, salt. Sodium alkynate. So having any acid, having any terminal alkyne will react with sodium. Acid, it's having acidic hydrogen. This is a methyl. So this is that sodium methyl. It will produce salt and hydrogen gas, right? So this is sodium. It is acetylene, na? Acetylide. Sodium alkynate. If you treat this two sodium ion you are giving, more the hydrogen will eliminate out. So if we want to attack it further on to another type of, what's it? Alkyne. As a type of alkyne light, to obtain a higher alkynes. So we use this reaction. Then, Himansh? Is it clear?
Yes ma'am, clear ma'am.
Next is reaction with Grignard reagent. Grignard reagent is RMGX. Partial negative, partial positive. So R, MgX. This is Grignard. R is alkyl group. Mg is magnesium atom. And X is any halogen. Negative part. Right? So Grignard reagent behave as a base as well as it is also act as nucleophile. As a base as well as a nucleophile. It behaves as both. So we are having, if we are having acidic H with substrate, so it will behave as base, more dominant, more priority. Means base, if acidic H is there, it we will think about whether acid base reaction will happen or as nucleophile it will act. So you will have to give the priority to basic nature of Grignard reagent. Okay, na?
Ma'am, what ma'am? Can I explain it?
I told you is, if we are having two options is that either we can do the acid base reaction
Yes, ma'am.
or it can behave as nucleophile. Don't worry, like there's no issues about it, because Grignard reagent is the topic that is discussed in other chapters as well in more detail. So as of now, we just have to look into the basic property of it. Okay. We'll not discuss now in this chapter about nucleophilic property of Grignard reagent. Yes, we'll discuss in next coming class, next coming chapters. Okay.
Yes, ma'am. Okay, ma'am.
So whenever we are having alkyne and we are attaching it to Grignard reagent. So Grignard reagent, alkyl group is partial negative and metal is partial positive. So R will take this hydrogen. It will be forming R plus RC triple bond C will attack now with MgX. So this carry energy plus MgX. Like this. Getting it or no? H positive will remove out from here, no?
Ma'am, in this RMGX, X is
any halogen. Like you can take an example of CH3 MgBr. We are attacking it to H C triple bond CH. So we will create CH4 plus H C triple bond MgBr like this.
ma'am, it will form as CH3 minus and MgBr plus, ma'am. But it should form as CH3 plus and MgBr minus. It should be formed, ma'am, because we can say CH3 is electron giving group.
CH3 sorry, CH3 plus. Okay, I got your point. See, Mg is a metal, right, Imanj?
Yes, ma'am.
Magnesium is a metal. So always remember that metal will never ever be positive in front of other non-metal, because we clearly know that carbon is not a metal, but magnesium is. So when we need to compare magnesium and carbon in between the two, it is electropositive. So Mg will be positive obviously because of its metallic nature.
No, but bromine as it can accept electron. It can form MgBr minus also. It can form, ma'am.
No, it's not like we are. See, there is a bond between CH3 and Mg, not with Br. Mg, Br is although along with each other, but the bond is in between CH3 and Mg. So that is why we will say that CH3 is partial negative and Mg is partial positive.
Yes, ma'am. Got
Getting it or no?
Yes, ma'am. Got it, ma'am.
You want me to repeat anything?
No,
Any doubt?
got it, ma'am.
No. The next reaction is with the NaNH2. We already know the reaction with NaNH2. So if we are having any alkyne having acidic H and we are reacting it with NaNH2, so our C triple bond C negative Na positive will be created and ammonia gas will be removed out. Correct?
Yes, ma'am.
And accordingly, if we want to attack this on any alkyne line, it can attack. Then is the test for. Next is the test for terminal alkynes. Test for terminal alkyne. First test is with tolerance rate. So when alkynes like are dispersed through tolerance reagent, that is ammonical silver nitrate AgNO3 plus so what will happen? It will be formed. Okay. NH4NO2 NO3 on ammonium nitrate will be forming. So this is white PPT of silver Sc dilite. So we can clearly identify that with tolerance reagent is giving white PPT. Means it is giving the test of tolerance with tolerance reagent. Getting it?
Means if we get a white paper, means it's an alkyne we need to say, ma'am.
Although it's alkyne having hydrogen, acidic hydrogen will react with tolerance reagent. The tolerance reagent is what? AgNO3.
NH4 void combination.
It is tolerance reagent ammonical silver nitrate. Silver nitrate. Okay.
Yes, ma'am.
Again, now when we are ammonical cuprous chloride. Now the next is with ammonical cuprous chloride. Here, a red PPT is formed. So R C Cu plus ammonium chloride plus H2. So here we are getting red PPT. Are you getting it?
Yes, ma'am, getting.
But if in place of cuprous chloride, we are taking ammonium chloride. Sorry, AuCO. We are taking AuCO. Ammonical, like previously it was ammonical copper chloride, no? Now it is ammonical silver chloride. So now what will happen? Our C triple bond C AU will be precipitated, which is yellow in color. Got it?
Yes, ma'am, got it.
So here we can identify that alkyl having acidic hydrogen is present, then only this reaction is happening. Otherwise, if it is not happening, we will not obtain these observations. Correct?
Yes, ma'am. Much yellow precipitate like that it will be formed, ma'am.
Huh?
It will form yellow precipitate.
Correct. Okay. So in next coming class, Imanj, we will start from addition reactions, and probably there are not that much reaction in alkynes. It's very simple only because we already discussed about the alkenes. Huh? So alkynes and after the alkalines, now very little thing is remaining from this chapter. And in aromatic compound, we already did discuss the aromatic compounds. Right now, we already discussed about it. Aromatic compounds.
Yes, ma'am. Definitions we have done, ma'am.
No, not aromatic compounds. How to aromatic, non-aromatic, anti-aromatic. That one.
Yes, but that one done, ma'am. Reactions we have not done, ma'am. See.
Obviously, we will do that reaction issues. But it is like I'm just confirming about that. Okay.
Yes, ma'am. Okay.
Okay then.
Yes, ma'am. Thank you.
All right, Manch.